Hello, everyone. I was I was trying to take you guys through this, and I screwed up the first video just because I was trying to rush through it, which is not what you want to do, right? When you take this exam, you do want to follow these guidelines. If you use less than 13 minutes here, then that'll allow you to spend more time on the other questions. If you take more, that means that you're going to have to budget your time a little better with the other questions. So on this particular problem, this plunger is going to push from A to B, and it's going to push with a constant force. And then there's some friction here between C and D, but on all other parts of the surface, there's no friction. And we're supposed to sketch the speed of the center of mass of this two-block system. Okay, that's our goal. And now that might confuse you, like, well, there's only a force over here. There's no force over here. The center of mass, when these two things get closer together, will start moving in this direction. Your Newton's second law equation, this is true for the system. The system's center of mass will accelerate if there is a net external unbalanced force. Okay, even though it's only acting on one of the masses, the center of mass of the system will accelerate if there is this force, which there is from A to B. And so from A to B, you have a constant net unbalanced force. And since that net force is constant, the mass of the system is constant, the acceleration of the system will also be constant. So in this first space from A to B, we're going to have a nice straight line, okay? A straight line on a speed versus time graph indicates a constant acceleration. So the center of mass is going to constantly gain speed, okay? Now from B to C, there is no more pushing. And if there's no more pushing, there's no more acceleration. And so from B to C, you're just going to have a horizontal line, because the slope of this graph is going to be the magnitude of your acceleration. From C to D, it's going to slow down because now there is a net force. That force is proportional to the normal force, which is going to be equal to gravity in this case, and mu. Both of those things are constant, so the friction will be constant no matter what the speed is. Since the friction is constant, you have a constant external unbalanced force causing a constant acceleration. But this time it's in the opposite direction of motion. So you're going to again have a straight line, but it's going to have a negative slope, indicating that we're slowing down. The closer you get to the axis, the slower your speed. And then from D to E, well, from D to F, there's no friction, right? And so as this block moves and it strikes this block, yeah, this block does slow down, this block speeds up, but there is no net external force to the system. If our system consists of block 1 and block 2, then the force that block 1 puts on block 2 is internal to the system, and therefore it's not a net external unbalanced force. And so from D to E, even though those two things collide, the center of mass of the system does not accelerate. There is no acceleration there. And so to complete your graph, it should be straight from D to E. Okay? Even though there's a collision at point E, the center of mass will not change its speed, because again, those forces are internal to the system. Okay, now I apologize for this writing up here because, again, I tried making this video, but then, yeah, I screwed up where the camera was. This puzzle piece doesn't belong in the video, but whatever. So this plunger is pushing right through the axis of rotation, which is the center of mass of this sphere. And so that applied force from the plunger cannot create a torque because it goes right through the center of mass. The force of gravity also goes through the center of mass, which is the axis of rotation here. It can't apply a torque either. And the normal force is also straight up through the center of mass. Yes, it's applied down here at the surface, but if you extend the line of action of the normal force, it goes right through the center of mass. So none of those forces can apply a torque. Only the force of friction, which is applied here between point C and D, will apply a torque. And a torque is what is required to change your angular momentum. So this might have been wordier than was necessary, but these are the things you should say, is that the angular momentum will only change when there's an external unbalanced torque. Okay? And so that's found on your formula sheet in this impulse momentum theorem for rotation. And the only force that applies a torque is friction, because the others go through the axis of rotation. And so friction being present between C and D will be applying a torque, and it will change the angular momentum. Okay, I hope you guys found that helpful. Probably tomorrow I will go through number 2, and the day after number 3. So I posted this to Schoology. Avail yourself to it. Give it a try beforehand, and during our daily call at 1 p.m., I can share with you online the grading rubric, and we can see how you would have done. Okay, guys, stay safe.